All right, we got a little Chapter 10 review sheet going on here. So just going through, our test is going to be on Friday. So this is the review sheet we're actually doing in class today, Thursday. So a little bit ahead of time here. If you get trouble, just feel free to hop in, check out some questions here, and we'll go through it. I'm going to upload this later tonight, so it'll be ready to go by the time class starts. So here we go. All right. Rectangle whose lengths are 10 and 6 respectively shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Which line could the rectangle be rotated around? So we have a couple options, right? If we go around this way, all right, and we form our cylinder going around this way, we have a radius of 10 and a height of 6. So if we're doing the volume here, right, it's going to be pi times the radius, which is 10 squared times 6. So this is going to be 600 pi, which is way too big. If we go down this way, right, and we form our cylinder going around this way, here we have a radius of 6, right? So it's times 10 with a height. So this is 6 squared times 10. That's 36. This is 360 pi, which is also too big. So we're going to have to think about this in terms of the lines of symmetry here. So let's talk about what happens if I go the line of symmetry going this way, so right through the middle. So this will be a vertical line of symmetry, okay? So if I spin this around this way, then the cylinder is going to get formed here, okay? So my radius here, if this side was 10, is now 5, and the height is 6. So the volume is going to equal pi times 5 squared times 6. This is 25 pi times 6, and that indeed is 150 pi. So that's a vertical line of symmetry, and that's going to be choice 3. Okay, choice 2, student has a rectangular postcard, we fold it half lengthwise. So we start with a rectangle, we're folding it half lengthwise, so we're going to end up with another, rectangular shape. So if I have a rectangular postcard, right, I fold it in half this way, I'm just going to get a kind of a smaller rectangle out of this, essentially, right? He continuously rotates around the folded edge. So if this is the folded edge right here, okay, then, right, what shape are we going to get? And then it's going to be a cylinder. Number 3, a plane intersects a hexagonal prism. So draw yourself a hexagon, right? Not too shabby. And then draw another one over here. Try to be the same here if we can, but ain't gonna be pretty all the time, right? Okay, and then the plane is perpendicular to the base. So if I cut a plane, right, this way, cutting down this way, right, what shape is that going to go if that's parallel to the base? Don't do that, people. That's parallel. Parallel to the base, we're going to get a pentagon. Perpendicular means I'm cutting this way, right here. Okay? See it? See it? Parallel? Perpendicular to the base. That plane right there is going to be a rectangle, people. Okay? So parallel to the base, here, we're going to get the same shape as the base. Perpendicular to it, cutting through. Doesn't matter where you cut it, right? Cut it at the top, it's going to look something like this. It's still going to be rectangular in shape. All right. Williams drawing pictures of a cone, cross sections, right circular cone below. Remember, right just means that this height here, the vertex, is right over the center of the cone. Which drawing cannot be a cross section? So we talked about this before, right? If I cut a plane going around parallel to the base, it's going to be a circle. If I cut it right down the middle through the vertex, we're going to get a triangle. And if I cut it at any point other than the vertex vertically down, we're going to get that rounded hyperbola shape here. So the one we're not going to see is a triangle. All right, or what am I talking about? Is a rectangle. Okay. If you cut it this way, so you're cutting around this way, that's where we're going to see this oval shape right here. Okay. So just keep that in mind. All right. So you can kind of get the ideas. Circle, triangle, oval. Can't get a triangle, or can't get a rectangle out of that. All right, number 5, we got a window. made up of a single piece of glass in the shape of a semicircle and a rectangle shown in the diagram below. Nearest foot, what is the area of the window? All right, so our window, it's a semicircle. So from here to here, these distances are both the radii, they're both the same. So if this is 10 feet, that shows us that this radius is equal to 5. Okay, we already have a rectangle right here, so the area of this rectangle, right, is just length times width, or base times height. It's 12 times 10, and this is 120 feet squared. The circle up top, right, we're doing the semicircle here, so the area is just, for a circle, it's 1/2 of pi r squared. All right, and then we're just plugging in 1/2 pi times 5 squared. That's 25. Half of 25 is 12.5 pi. So if we were doing exact area, totally the exact area, in terms of pi, remember we keep pi in our answer. It's 120 plus 12.5 pi. We are going to bust out the calculator though, and we are going to type that in, all right, and round it out accordingly. So we're just going to do 120 plus 12.5 pi, and there's our answer. And then we're going to the nearest foot, so that's 159 feet squared. Okay, there we go. All right, length of a window of a base of rectangular prism and width of a, why am I stuck on windows here? The length and width of the base of rectangular prism are 5.5 and 3. The height of the prism is 6.75. Find the exact value of the surface area of the prism in square centimeters. I don't exactly know why exact is there, so I think we're just knowing that it's not going to be rounded. It's whatever the decimal comes out to be. So we got ourselves this rectangular prism here. The base, so call that our base, right? We have 5.5 and then 3, and then we're going up this way. So this is 6.75 here. So not exactly drawn to scale, but you get the idea. So the surface area formula, remember, is the lateral area plus 2 times the area of the base. For a rectangular prism, the lateral area is the perimeter of the base times the height, and the area of the base here is 2 times the length times the width. That's it. So the base is here, right? The sides are 3 and 5.5, so it's like 2 times 3 plus 2 times 5.5. All right, I like using parentheses instead there. Boom, times the height, which is 6.75. 7.5, not just the 5 thing there, right? And then we're adding on the area, the 2 times the area of the base, which is 3, okay, times 5.5. All right, so you can type all this in the calculator at once if you'd like. It'll work out nice for you. We'll go part by part here just so we can kind of get the idea of what's going on. So this is just 6 plus, this is 11 times 6.75 plus, and then we got 2 times 3 times 5.5. So this ends up being 33, right? 6 times 5.5. So this is just 33. So it's really 17 times 6.75. And this is equal to 114.75. And then we're adding 33 to that. And this comes out to be 147.75. And once again, that's in centimeters, so centimeters squared. Okay? 2 stacks of 23 from below. One stack forms a cylinder, the other does not. Use Cavalier's principle to explain why the values of these 2 stacks are equal. So Cavalier's principle uses the fact that we have cross sections, these quarters, okay, all have the same area. All right, so the area of the base, the cross-sectional area, all these quarters, they have the same amount of quarters, the area of the quarters are the same, and with the height is the same, meaning the same number of quarters, therefore the volumes are going to be the same. So we're going to say the cross-sectional areas of the, you could just say like even just the cross-sectional areas are the same. Here we'll just mention the fact that we have quarters, so of the quarters are the same, and the height, which is essentially the number of quarters, right, is the same. Therefore, the volume must be equal. Remember, volume is the area of the base times the height. So that's why we're going with the cross-sectional area, the area of the base, and the height is the same, okay? A fish tank is the shape of a rectangular prism. Not drawn to scale, people, all right? It's got dimensions of 14, 16, and 10. So let's go 14, we'll go 10 here, and 16 going that way, okay? And the tank contains 1,860 cubic inches of water. They want to know what percent of the fish tank is empty, okay? So at some point, we've filled it up. We don't know if it's full or not, and the way to tell if it's full is just to check to see what the volume is, right? If our cubic inches of this is equal to 1680, then we're full. So it's at 0%, right? But if our volume is more, let's say it's 2,000, then we know we have a difference. And remember, percent is equal to the part over the whole, okay? Times 100. All right? So that's what we want to keep in mind here is as we calculate this out, part over whole. So what's the part that's empty over the entire volume? And that's going to give us a decimal. Shift it over to the decimal places, and we got ourselves a percent. So let's do the first. Let's check the volume and see if this thing is full. So it's length times width times height, area of the base times the height. So 10 times 16 times 14. And we're going to get 2,240. So obviously this is not full, right? Okay. So the difference between those, 2240 minus 1680, is equal to 560. This is cubic inches, right? Inches cubed. All right. So far, so good. And this is the amount of empty space. So for a percentage, we're going to do 560 part divided by whole, 2,240. And that's equal to 0.25. So the fish tank is 25% empty. It's quarter empty. Okay? And that's it for number 8. Oh, it's multiple choice. Choice 2. All right. Number 9. Regular pyramid has a height of 12 centimeters and a square base. The volume of the pyramid is 256 cubic centimeters. How many centimeters are the length of one of the sides of the base? All right. So keep in mind, volume formula for a pyramid is 1/3 the area of the base times the height. Remember, pyramids and cones only have one base, so it's 1/3 of the volume of the volume of the like a cylinder or the prism. Okay, so we're filling in. 256 is equal to 1/3 times the area of the base, which we don't know, but we do know it's length times width. And if you want, just draw yourself a little picture, right? We have draw yourself a good little picture here, right? So we have a square base, we'll call the sides X, right? Kicking a point above, dragging the lines out, the height drops down to the middle, and this height is 12 centimeters, okay? So if you're doing the length time, if you're doing the area of the base, you can just keep it as B. But remember, if this is a square, this is really just X times 12, okay? And then easily, 1/3 of 12, right? We can do 1/3 times 12, so 256 here is going to equal 4. And X times X, remember, is X squared. So essentially, we're just solving for X here. So if I divide both sides by 4, okay, and I believe we're going to get 64 here. We will indeed. We're going to bust out our square root symbol. We're going to get 8 for X. We can't get a negative answer, so we'll stick with 8. And that is the length of one of the sides of the base. Also, it's multiple choice, people. So you could also just take these answers, plug them into this formula, and see if it equals 256, right? Multiple choice. You can also do that as well. But if it's not multiple choice, you're going to need to show some work. There's your work, and you're good to go. Number 10, we got a candle maker. Using a mold to make candles like shown below. The height of the candle, so going from top all the way down to the bottom and perpendicular to the base, is 13 centimeters. And the circumference of the candle at its widest measure, which means all the way down here at the base, right? The circumference is equal to 31.416 centimeters. So we want to use modeling to approximate how much wax, the nearest centimeter, is needed to make this candle. So essentially we want to know the volume, right? Because it's solid wax. So let's do it. So the first thing we're going to need, if we think about the volume of this cone, is 1/3 area of the base, pi r squared, times h. And the only thing I don't have here is the radius. But they do give me the circumference. So I'm going to have to use the circumference formula, which is 2 pi r, to solve. 31.416 is going to go in for C. And then I'm just going to divide by 2 pi, and we'll have our value of r. Now you can keep the decimal as is, or like you're going to see if I divide out, I'm going to get this crazy like 5.000001. So what I'm going to do is I'm going to take half, that's this part, right? And I'm going to get 15.708, and I'm going to leave it divided by pi, because to me that's a little bit easier to write out than this decimal. But feel free just to write out this pi.000011692. Remember, we're not rounding until the very last step, so just keep using that number, okay? And we're going to plug in. So volume equals 1/3 pi, that we're using the button on the calculator. R, we know it's down there. It's 15.708 over pi for us, times squared, and then times h, which we know is, from the problem, is 13. So we're just going to type those lovely numbers in. So we got a little 1/3 action, right? 1/3. We're going to throw in the pi. We got our answer from above, so if you want to go ahead and use the answer button in there, feel free. If you want to type it in, like I'm about to do, 15.708, because I'm a rebel, and that's just how I roll. Squared, and then times that by 13, and there we go. Okay, and that's the cubic centimeters. So how much wax? Nearest cubic centimeter. Go back and check to make sure you know what to round to. So this is 340.3407959. We're rounding the nearest. We're looking at the next number only. It's a 3, so it's 340 centimeters cubed. Okay, so keep that in mind. All right, a sphere is inscribed inside a cube. That means that it's the sides of the sphere are touching the sides of the cube. Okay, so we have like that old like Christmas ornament box here, right? The sphere is touching the sides here. Okay. So the distance from the diameter all the way across is the same as the part on the bottom. So if the edges of the cube are 6, that means the radius is half of that, it's 3. Okay? So volume in terms of pi, remember it's 4/3 pi r cubed. Volume is cubed, so this r should have a 3 on it. Don't put a 2 on there, people. Okay? If there's a 3 here, there's a 3 that goes here as well. All right? We're going to plug in. So it's 4/3 pi times radius 3 cubed. All right? Which, believe it or not, it's actually the same as 4 pi r squared, because the 3's are going to cancel here. But we're going to leave that fun fact of the day to your imagination here. So, boom. Got it. Oh, wait a minute. It says in terms of pi. I don't want to do that, right? So I just want to do 4/3 times 3 squared. And I get 12. So this is just equal to 12 pi. Okay? That's it. That's it. Okay. Slide it over. Oh, we did it wrong again. Don't do that. Go do that 12 pi. What did I just say? I said cubed here. And look what I did. Squared. Epic fail. All right. Let's get that back. Let's go to the third. Hit it. Oh, I see the problem. It did an extra exponent here. Get out of town. I want that to be 3. There we go. So this is actually 36 pi. And that makes sense. I told you that this cancels out here, which makes this 9. And then 9 times 4 is 36. All right. And there we go. And look at 12 pi with an answer. So they're banking on the fact that you're going to use squared, and then they're going to be like, gotcha. So just be careful, okay? Don't fall into that trap. Number 12. This is a fun question. All right. I use that term loosely here. I enjoy it, but you know how that works. New streetlights will be installed along the section of highway. The post for the streetlights will be 7.5 meters tall and made of aluminum. The city can choose to buy posts that are shaped like cylinders or posts shaped like rectangular prisms. The cylindrical posts have a hollow core with aluminum 2.5 centimeters thick and an outer diameter of 53.4 centimeters. The rectangular prism posts have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters each side. The density of the aluminum is 2.7 grams per centimeter cubed, and the cost of aluminum is 0.38, so 38 cents per kilogram. So make sure we're in kilograms, right? We catch the kilogram right here, and look at already, boom, grams. We got a problem, right? So if all posts must be the same shape, which post design will cost the town less? So really we have to do both, right? And then compare. And how much money will be saved per streetlight post with the less expensive design? This is a Regents question, people. 6-pointer all day long, all right? So let's go through it. First streetlight. Okay, let's take a look at the streetlights first because they're a little tricky. And then we'll, actually, you know what? We talked about this before. Do the conversion right away. So we want to do 2.7 grams, and we want to turn that into kilograms, right? So we want kg on the top, grams on the bottom. 1 kilogram is 1,000 grams, and you're dividing this bad boy. So 3 decimal spots over is going to be 0.0027 kilograms, okay, per kilogram. That's going to be per cubic centimeter, okay? And that's the density now. So this is the density we're using. This is a new one, okay? Notice it says centimeters cubed, and these are in centimeters, so we're good to go. If this had meters cubed, we'd have to convert these as well, okay? Uh-oh, we do have a meters up top, so we do need to switch this out. So 7.5 meters, right? And we want to convert this into centimeters. So 1 meter is 100 centimeters. And we're going to move this 2 spots. So this is equal to 750 centimeters. All right, and that is going to be the measurement here. So keep in mind that we are replacing those two with our unit conversions here, okay? All right, so we have a cylindrical light pole. And it's just a post, so really think of it like there's no top on it here, okay? And what happens is it's got a hollow core. So there's a hollow core here. Now, this is important. It says the aluminum is 2.5 centimeters thick, okay? And an outer diameter of 53.4. So if you're going from one side all the way to the other, this diameter is 53.4 centimeters, all right? So this is not exactly drawn to scale, right? This would be a lot bigger. So if you're actually looking at this, it would really look something like this. All right. It's a big guy. And then it's like this. Okay? So from here to here, right there, that's 2.5 centimeters. This all the way across from there to there is 53.4 centimeters. So this question is obnoxious for a couple of reasons. One of the big ones being that we actually have to calculate 2 different volumes and subtract them, right? I need to know what the volume of the entire cylinder is, and then I need to know the volume of this inner cylinder that doesn't have anything in it, this little core. When I subtract them, I'll have the volume around it. Okay? So let's do the whole cylinder. Volume of, let's say, the outer part, right? So it's still going to be, or actually we should just say, let's just say the whole thing. Let's call it whole. Whole. So it's just pi r squared h, okay? We know the height, once again, is 750 centimeters. So it's pi times the whole thing, all the way across, right? 53.4. We want half of that now. So that's 26.7 times h, which we know is 750. And we're just going to leave this in terms of pi. There's no reason to give me some crazy decimal here, okay? And we get 20,025 pi, and this is centimeters cubed, okay? That's it. Oh, we did it wrong already. The squared, people. Look at those squared. Let's try this again. 26.7 squared times 750. There we go. So it's 534,667.5 pi centimeters cubed. There we go. That's the whole. All right. Now we just want to do the core. So what's the volume of the core? Okay. So we're taking off 2.5, which is really just 5. So if this radius here, right, from there to, let's go this way, from there to there is 26.7 minus 2.5. So 26.7 minus 2.5. That's the radius of the core. Okay. So if we do ours, we're going to end up with 24.2. That's our new radius. So it's pi, right, r squared times h. All right. So, oh, h once again is 750. Let's do it right this time. 24.2 squared times 750, not 4. Okay. We get 439,230 pi. Okay. That's the volume of the core. So our volume of the pole, for the cylindrical pole, is the difference. And I'm actually going to give you the whole answer here, okay? Because I want to be able to compare it to the rectangular prism, so we want the whole thing. So it's, bring that number down, 534,667.5 pi minus 439,230 pi. Let's just double check that. Enter, and there we go. Is 299,825.7489 centimeters cubed, right? That's our volume of the pole. Okay, rectangular prism time, right? So we got ourselves same concept here. We got a rectangular prism top, right? Once again, we have a core in the middle, and then we are dropping down, right, the street pole to the ground type thing. So it looks, something like that, okay? So same thing, square base. This measures 40 centimeters all the way across, and this piece right here, from there to there, that's 2.5, okay? So the inner one, 2.5 here and 2.5 there, is missing 5 centimeters. So the inner guy is 5 centimeters long, right? There's a 2.5 here and a 2.5 there. So if you take 40 and take away 2.5, that's going to give you 35, and that's the inner square, okay? So we're going to do the same thing. We're going to do that square here. We're going to do the rectangular prism, the outside, the whole thing. We're going to do the core, and then we'll subtract, okay? And that should leave you with what we're looking for. All right? For those of you, by the way, are thinking, well, if I just did a cylinder and just did 2.5 for the radius, right? 2.5 squared times 750, notice you don't get the same thing. So you have to actually do the volume of the poles and subtract it, okay? So let's do the same thing. Volume of the whole thing, right? Length times width times height. It's a square base. So length times width times height. The length and the width are both 40. And once again, our height is still 750. Okay? And then we're just going to do it to it. So we're going to do 40 times 750. All right. And then we get 1, 2, 3, 4, 5. There we go. 1,200,000. 1, 2, 3, 5. 1, 2, 3. There you go. And that's centimeters cubed. All right. And then we want to do the core. So now remember, it's 35 and 35 this time. So it's Still length times width times height, 35 times 35 times 750. All right. And this is 918,750 centimeters cubed. All right. And so our total, the volume of the rectangular pole, right, is the difference. So 1,200,000 minus 918,750. This is equal to boom, 281,250. So those of you who are looking at the original are going, oh, it's definitely more. It actually is not. Okay. So you can see that this one is actually going to be lighter, but we still have to calculate out the total cost. So once again, the cost is going to equal the weight here, right? We haven't even done that, right? We still have to multiply times our 2.7 grams here, right? We convert that. We didn't convert that. Yes, we did right here. Boom, right? So our weight, our mass, is going to be that volume. So we'll do volume of the pole. Well, we'll write down 299,825.7489 times 0.0027, right? Is going to give us our weight. All right, let's go get that guy. 299,825.7489 times 0.0027. Boom. We get 809.52952 kilograms, kgs, kilograms. All right. And then our total cost is going to be that number times 38 cents. So 0.38 times that 809.5, get back here, 29522. We're running out of room. Okay. Times 0.38. We gotta close that guy. Let's try this again. I think I broke it. There we go. Boom. Times 0.38. What's up? It is equal to $307.62 per pole. Okay. Whew. All right, you ready? And same thing on this one. So we have our pole. Okay, so we're going for the mass or the weight here. So we're going to do the rectangular pole. That's equal to 281,250 times 0.0027 is going to be equal to 281,250 times 0.0027. Right? Yeah. Boom. Hit it. 759.375 kilograms. So our cost is equal to that 759.375 times 0.38 for our cost here. And we get $288.56 for our total cost. So, which post is at the count list? We want to go with our rectangular prism. All right. And then we want to subtract. So we just do that $307.62 minus the $288.56. Okay. And, right, in fact, it will cost $19.06 less per pole. And there we go. All right. Number 13, a right triangle has lengths of 5 meters and 12 meters. Is rotated around the leg that measures 12 meters. Find the volume in the three-dimensional solid that is formed. So, right triangle, boom, 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 12 and 5 meters. Right, rotate along the line to 12, so it's going around this guy. So we're forming a cone, right? That's our height. That's our radius. So volume is equal to 1/3 area of the base times the height. Volume is equal to 1/3 pi r squared h. Okay, plug it in. 1/3 pi. We'll just leave this in terms of pi here, so exact times, and then we have 5 squared times 12. So it's really 25 times 4, which should just be 100 pi, and we got meters squared all day. If you don't believe me, 1/3 times 5 squared times, nope, that's not minus, times 12. Boom, there's 100, okay? And the last one, area of a cone, base of a cone is 16, the height is 10. Find the area of the cross section that is a distance of 5 from the vertex. So, if we have a cone, not a cone, but wow. Yeah, don't do that. Circle first. Coming down from the triangle. Boom. Okay. Area of the base is 16. The height is 10. If we have a distance, it's 5, right? So we draw another circle. So this is now 5. They want to know what's the area. This is another ratio question, right? So the scale factor here, the ratio of the sides, is 5/10, which is equal to 1/2. The ratio of the areas is that number squared, which is 1/4. So if the area of the base of the cone is 16, right? 1/4 is equal to 16 over, I don't know, go find out. Cross multiply, 4x is equal to 16, and x is equal to 4. So the area of the smaller base is 4 units squared, okay? So area of the cross section is 4 units squared. And if you're watching the video and you've made it this far, you won't have to know how to do this for your test. All right. Enjoy, guys. See you later.